In October 2017, astronomers detected an object hurtling through our solar system, unlike anything seen before. Named Oumuamua, meaning scout in Hawaiian, it moved at incredible speed and followed a trajectory that suggested it came from beyond our solar system. Its elongated shape and mysterious acceleration sparked debates worldwide. Was Oumuamua a natural fragment from a distant star system? Or could it be an artifact of alien technology? The true nature of this cosmic visitor remains one of astronomy's greatest puzzles. Cold open, a visitor from the stars. It came from nowhere. No warning, no trail. Just a flicker of motion in the darkness. Too fast, too strange, too foreign to be one of ours. In October of 2017, a telescope on the Hawaiian island of Maui made a silent discovery that would shake astronomy to its core. The Pan-STARRS Observatory picked up an object moving fast, faster than anything normally bound by the gravity of our sun. Its trajectory? Impossible. Its origin? Interstellar. This object wasn't from here. It was a messenger from the stars. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar arriving first. It was the first interstellar object ever observed in our solar system. First observations and global response. At first, the discovery didn't seem earth-shattering. Space is filled with rocks, comets, asteroids, fragments of debris. But this one was different. It wasn't just passing through. It was fleeing. It had already zipped past the sun, past Earth, and was now speeding out of the solar system. It was moving at 315,000 kilometers per hour, far too fast to be captured by the sun's gravity. It had entered our solar system and was now leaving it. Astronomers around the globe knew they had just days, maybe weeks, to observe this mysterious traveler before it vanished forever. The shape, stranger than fiction. As the world's telescopes turned toward Oumuamua, they noticed something odd. The object's brightness was changing dramatically, up to 10 times in regular intervals. This meant one thing: it was rotating. But not like a sphere or a chunk of rock. The changes suggested an extreme, elongated shape, either like a giant cigar or a flattened pancake. And it was tumbling, not spinning smoothly, but chaotically flipping through space. We had never seen anything like it. Most asteroids and comets are irregular, but nothing this long, this flat, this reflective. If you drew this on paper before 2017, no planetary scientist would have believed you. The path, an origin beyond our sun. Its path told us it didn't come from the asteroid belt. It didn't loop in from the Oort cloud. No, this object came from interstellar space, the vast freezing void between stars. It entered the solar system from above the plane of the planets, made a sharp turn around the sun, and exited with surprising speed. The direction? Near the star Vega, in the constellation Lyra. Vega is about 25 light-years away, and yet Oumuamua didn't come directly from it. Vega wasn't even near that point when Oumuamua would have left. This visitor had likely been traveling through the galaxy for millions, maybe billions of years. The acceleration, the first red flag. But it wasn't just its shape, or its speed, or its origin that raised eyebrows. It was what happened after it passed the sun. Oumuamua accelerated. Yes, just a tiny bit, but measurably, undeniably. This wasn't expected. Natural objects follow precise gravitational arcs. If something speeds up without propulsion, we expect to see gas jets, like a comet releasing material. But there was no coma, no tail, no visible outgassing, nothing. It was moving as if something invisible was pushing it. Was it sunlight pressure? Could it be radiation from the sun pushing on a wide, thin structure? The numbers didn't add up, but the mystery was only deepening. A question no one expected. By the time the public caught wind of the story, scientists were already divided. Was it a comet with no tail? An exotic iceberg made of hydrogen? Or something else entirely? Then came a voice from Harvard, Dr. Loeb, who posed a question that no one in astronomy wanted to answer publicly. What if it wasn't natural? What if this was a probe, a derelict solar sail, a technology sent, or lost, by intelligent life? The debate exploded. The object was already too far to study further, but its mystery had only begun. For the first time in history, we had seen something that didn't make sense, and it came from the stars. What made Oumuamua so strange? When astronomers first detected Oumuamua, they did what scientists do best. They classified. A fast-moving object in the solar system? It must be a comet or asteroid. But things didn't line up. Comets outgas. They leave trails of ice and dust as sunlight vaporizes their surfaces. Oumuamua? Not a wisp. No coma, no tail, no dust. Then maybe it was an asteroid, a dry rock, but asteroids don't accelerate on their own. With every assumption tested, a new anomaly appeared: shape, spin, and brightness. Then came the object's light curve, the pattern of brightness as it rotated. It changed dramatically, over 10 times brighter at some angles than others. This told scientists that the object was highly elongated, the most stretched-out shape ever recorded in space. Initial models painted it as a cigar, long and narrow. Later, some argued it was more like a pancake, wide and flat. But both models agreed on one thing. This was no typical rock. It was either highly reflective or extremely thin, or both. It also tumbled chaotically, not spinning in a steady axis, but flipping irregularly, like a falling plate in slow motion. The acceleration revisited. The strangest trait of all was Oumuamua's acceleration. As it passed the sun and moved away, it sped up ever so slightly. This was the moment science held its breath. Non-gravitational acceleration in space isn't unheard of. Comets do it all the time. But this object had no visible emissions, no gas, no debris, no evidence of thrust. Could sunlight pressure alone account for the motion? Maybe, but only if the object was extremely thin, like a sail. Now scientists were looking at something they had never seen, an object behaving like a controlled, engineered structure, but with no one controlling it. Origin and entry vector. Where did it come from? Oumuamua entered from the general direction of the star Vega, about 25 light-years away. But Vega wasn't near that location when Oumuamua would have passed it. In fact, the object had no obvious parent system, no trail of others like it, no matching velocity with nearby stars. It came in fast, and alone. Astronomers calculated that it had likely been traveling through the galaxy for millions, perhaps hundreds of millions, of years before this chance encounter. Think about that. A lonely fragment crossing the Milky Way in silence, finally brushing past one star and one species with the tools to notice. No perfect fit, a scientific anomaly. The scientific method thrives on explanation, but Oumuamua resisted classification. Too dry to be a comet, too thin to be a rock, too fast to be captured, too precise to be ignored. It didn't fit the mold of any natural object we had studied. Some theorized it was a nitrogen iceberg, a fragment from a distant Pluto-like world, but such materials sublimate quickly. Others proposed hydrogen ice, but that would have evaporated long before reaching our solar system. The hypotheses kept coming and failing. Nature is strange, but this was stranger. And some scientists began to wonder aloud, maybe we were missing the point. Natural explanations, the scientific debate. The first idea was the simplest. Oumuamua must be a comet, but a dormant one that had lost its volatile materials long ago. That would explain the lack of a tail. No gas, no coma, just a dry husk of a comet aged by interstellar travel. But there was a problem. Even dormant comets, when they heat up near the sun, show some signs of activity. A little jet. A faint release of particles. Some kind of trail. Oumuamua gave us nothing. Not even the tiniest sign of vapor or dust, despite careful observation. The hypothesis didn't hold. The hydrogen iceberg theory. Next came a more exotic idea, a hydrogen iceberg, a frozen chunk of molecular hydrogen formed in a dense interstellar cloud. The theory said, as the object approached the sun, it sublimated quietly. Hydrogen gas is hard to detect. Maybe we just missed it. But this idea required incredibly specific conditions. First, hydrogen ice is extremely fragile. It would evaporate in interstellar space, long before reaching our solar system. Second, forming such an object naturally and preserving it over millions of years would be nearly impossible. Most scientists called this one beautiful, but implausible, the nitrogen shard proposal. Then came the nitrogen shard theory. What if Oumuamua was a fragment, chipped off the frozen surface of an exo-Pluto? Nitrogen ice, like that found on Pluto's surface, could reflect sunlight well, and as it sublimated, it might produce the acceleration we observed. This was one of the most respected natural explanations. But again, it required perfect conditions: an exoplanet with nitrogen crust, an impact strong enough to eject a shard, and then a billion-year journey through space without disintegration. And still, no nitrogen was detected, no signature in the object's spectrum. It explained some things, but left many others untouched: dust, pebbles, and the limits of imagination. More ideas poured in: a dust pancake held loosely together by electrostatic force, a sliver of carbon foam, even a cloud of pebbles in a transient formation. Each theory pushed the boundaries of natural object formation, each one strained under its own complexity. And with every new guess, something became clearer. The scientific community was grasping for answers and not finding them. Nature is creative, but nature also leaves clues. And with Oumuamua, the clues were contradictory, incomplete, and rapidly fading. A scientific dilemma. By 2018, the data was mostly gone. The object was too far to observe. All that remained were questions. And with no perfect fit in the natural world, the debate grew louder. Was this just a bizarre rock, the strangest one ever seen? Or had we witnessed something more? For every natural explanation, there was a hole. For every hypothesis, a contradiction. And in this vacuum of certainty, one voice said what few dared. What if this wasn't natural at all? The alien hypothesis, Avi Loeb, and the controversy. While most scientists searched for a natural explanation, one man dared to ask a radical question. Dr. Avi Loeb, theoretical physicist and chair of Harvard's astronomy department, published a paper that turned the scientific world upside down. What if Oumuamua was artificial? A spacecraft, a probe, or a fragment of alien technology? Loeb wasn't writing science fiction. He was doing what science demands, following the data wherever it leads. The case for the artificial, Loeb noted Oumuamua's non-gravitational acceleration, the lack of outgassing, the strange shape, the high reflectivity, the precision of its trajectory. He proposed a plausible mechanism. Oumuamua could be a light sail, a thin reflective surface pushed by solar radiation, like a sail catching wind. Solar sails are not just theory. We've built them on Earth. NASA's Sunjammer and the Planetary Society's light sail prove the concept. What if Oumuamua was a derelict light sail, drifting through space for millennia? A lost piece of alien technology, not functioning, but evidence. Loeb's suggestion: we don't know what it is, but it acts more like technology than nature. The backlash. The reaction was swift and brutal. Astronomers accused Loeb of sensationalism. They said the data wasn't enough, that extraordinary claims require extraordinary evidence. Some dismissed it outright. Others accused him of undermining public trust in science. But Loeb didn't back down. He argued that ignoring the artificial hypothesis without testing it, that was unscientific. He wrote, "If we never consider the possibility of alien technology, we will never find it." Science isn't about comfort. It's about courage, media storm, and public fascination. The world listened, not because they were ready to believe, but because the question was electric. What if this was it? Our first brush with extraterrestrial intelligence? and it came and went before we noticed. Loeb became a media figure, featured in interviews, podcasts, debates. His book, Extraterrestrial, became a bestseller. And through it all, he returned to one truth. The object acted unlike anything we've ever seen, and we should be open to all possibilities. Beyond Oumuamua, the Galileo project. But Loeb didn't stop with Oumuamua. In 2021, he launched the Galileo project, a scientific initiative to systematically search for evidence of alien technology. Not fantasy, not conspiracy, data, observation, analysis. The goal? To build a global network of instruments that can track unidentified aerial phenomena, interstellar objects, and potential technological signatures. For the first time in history, a mainstream scientific effort was dedicated not just to what if, but to what is. Oumuamua might be gone, but its legacy had just begun. Searching the skies, SETI, breakthrough, and fast response. If Oumuamua was artificial, could it be transmitting? That was the question that brought SETI, the search for extraterrestrial intelligence, into the picture. Using the Green Bank Telescope in West Virginia, SETI's Breakthrough Listen initiative trained its instruments on Oumuamua. For hours, they scanned across 4 radio bands, listening. The result? Silence. No pings, no pulses, no modulation. But that doesn't mean there was nothing to hear. It could mean the object was inactive or already dead. The problem of timing. There was one critical problem: timing. By the time most of the world even knew about Oumuamua, it was already on its way out, fading fast, growing too dim for most telescopes to track. The window to study it had been just weeks long, a blink by cosmic standards. We had missed our chance. If it had carried a signal, a signature, or a structure, we couldn't see it now. The call for rapid response. Oumuamua taught us a painful lesson. We're not ready. Ready to study something fleeting, ready to launch a probe, ready to capture an interstellar visitor while it's here. Astronomers began calling for a fast response program, telescopes and satellites that could pivot quickly to study strange objects the moment they appear. We need detection, we need observation, we need a plan. The search for the next Oumuamua. In Chile, a new telescope was being built, the Vera C. Rubin Observatory. Its mission, to scan the entire sky every few nights. Once complete, it will offer us unprecedented power to catch fast-moving, unexpected visitors like Oumuamua. Astronomers are hopeful. If something comes again, we'll see it earlier, track it longer, learn more. But that's not enough. Next time, we may want to do more than watch. We may want to intercept. The interceptor era. In 2020, a radical idea emerged. What if we could chase Oumuamua down? That's the premise of Project Lyra, a proposed mission to launch a spacecraft that could catch up to Oumuamua in deep space. It would require high-speed propulsion, long-duration flight, and intercept capability beyond anything we've built. It's a long shot, but it's no longer science fiction. With time, funding, and ambition, we could pursue the next one. Because one day another interstellar visitor will come, and next time, we might not let it leave without answers. Theories and cultural impact. By the time the scientific community caught its breath, the public imagination had already taken flight. Oumuamua, this strange, silent traveler from another star, was no longer just a scientific anomaly. It was a symbol. A messenger, a mystery, a mirror reflecting our deepest questions about who we are and who else might be out there. Rama Revisi. In 1973, Arthur C. Clarke imagined an object like this, a massive alien ship entering the solar system, silent, cylindrical, passing by before anyone could fully understand it. He called it Rama. The resemblance was uncanny. Oumuamua wasn't a 50-kilometer-long spacecraft, but the echoes of Clarke's vision were impossible to ignore. Many asked, is science fiction predicting reality or preparing us for it? Conspiracy and curiosity. Where mystery flourishes, conspiracy follows. Speculation soared. Was Oumuamua a secret NASA cover-up? A crashed probe? A galactic messenger we failed to decode? Some theories were wild, others sincere, and behind the noise, a quiet hunger, the need for something greater, for connection, for meaning in the stars. Oumuamua didn't just challenge science, it reignited our cosmic imagination. Philosophers and thinkers join in. Oumuamua crossed disciplines. Physicists debated it, journalists covered it, but philosophers and artists interpreted it. What does it mean that we could miss a visitor from the stars? Are we ready, emotionally, spiritually, for contact? Some saw Oumuamua as a test, a riddle posed to a species still learning how to look up and listen. A shift in the cosmic narrative. Oumuamua didn't send us a message, it was the message. Proof that our solar system is not isolated, that the galaxy is alive with movement, and that something, or someone, may be out there watching. It invited us to imagine more, to explore harder, to question deeper. Because in the silence of space, one object whispered something unforgettable. You are not alone. The next interstellar visitors, the next interstellar visitors. It was just a rock, or maybe not. It was a ship, or maybe not. It accelerated, it reflected sunlight, it tumbled, it vanished. But what Oumuamua truly did was reignite the greatest question ever asked. Are we alone? The real discovery. We may never know what Oumuamua was, but it changed everything. It reminded us that our solar system is not closed, that space is not still, that interstellar visitors are not myth, but measurable. For the first time, humanity witnessed an object from another star, not on a screen, not in a book, but in our own skies. The Galileo Project and a new kind of science. In the wake of this mystery, a new effort was born. The Galileo Project. Its mission, to search scientifically for evidence of extraterrestrial technology, not only in space, but here on Earth, in our skies and oceans. No speculation, no stigma, just data, and the courage to follow it. Because if we dismiss the unknown out of fear, we miss the truth when it finally arrives. The larger legacy, Oumuamua is now gone, a blur in the dark, but its legacy is alive. It pushed scientists to question assumptions, it challenged us to stay curious, and it dared us to imagine something more. Not just stars and planets, but intelligence, direction, intention, mystery. Whether natural or not, it reminded us of our smallness and our potential. Maybe we were watched. Maybe we weren't. Maybe Oumuamua was just a rock, or a relic, or a message, or a memory. Whatever it was real. It came, and it left. And now we wait for the next. Because one day, maybe soon, the stars will whisper again. And this time, we'll be listening.